This conference will now be recorded.
Right, let's start today's session. In the last session, we were discuss about some types of variables and methods. In object-oriented programming, three types of variables are allowed in class. Three types of variables are allowed in class. One is instance variables. These are all called object level. And next one is static variables. These also called as class level variables. Next, local variables. These are method level. At the same time, three types of methods are available. Three types of methods are allowed in Python object-oriented programming class. What are that means? First one is instance methods. Instance methods. Next, class methods. Class methods. And next, static methods. These we discussed in previous session. Types of variables, types of methods. But in this session, I would like to discuss about static variables, in which places we can access, and how to delete static variables. In the previous sessions, only we discuss about static variables, the variable which is declared inside the class but outside of the method is called static variable, I said. But I have not discussed much more about static variables. The reason is they have to complete this instance method, class method, static methods. Then after, we will see today where in which places static variables we can declare and how to delete them also we'll discuss now. Okay. Generally, okay, still PyCharm is loading. Now coming to this static variables, in which places we can declare, where we can access static variables, I'm trying to discuss. So actually, where we can access means place number one, inside the constructor. Inside the constructor, we can access static variables by using self or class name through also. Yes, inside the constructor, by using self or class name through, we can access static variables. Okay, this is point number one. Next, point number two, inside the instance method. We know already instance method what is. Inside the instance method, we can declare, we can access by using self or again class name. Next, inside the class method, inside the class method also we can access static variable by using CLS or class name, because here CLS is the class variable, while declaring class method the first variable is CLS only. So inside the class method we can access static variable using CLS or class name. Fourth one is inside the static method we can access static variable by using class name only. Class name only. Why? Because you know that very well. While declaring static method, we don't use any self or any CLS variable. Static method declaration time, we don't use any self or any CLS. Only class name we can use here. But last one, outside of outside of the class, outside of the class, we can access static variables by using object reference or class name. Yes, by using object reference or class names are outside of the class. Outside of the class by using object reference or class name only. So these places we can access static variables clearly. Let's see the practical implementation here. Actually, my PyCharm editor is not loading properly. Still, it is taking time. Please wait few minutes. Why this is taking time today? It's not loading properly. Yeah, no, it's okay. Please wait 2 minutes. See, actually, this is not your project. Let me open your project. Click on File menu and click to open and select your project location where it is there. So your project is present on G drive. Now it's almost ready. Now let's see practical implementation of these statements where we can access in static variables here. Inside the constructor by using self or class name. Inside the instance method by using self or class name. Inside the class method by using CLS or class name. Inside the static method by using class name only. Outside of the class by using object reference or class name only. Okay, let's flip to program. Now here I'm taking a new class here. We are in test 9 or yes, test 9. So I'm creating a class here. Class keyword it is test is a class name. I'm declaring static variable 100. This is static variable. This variable in which places we can able to access we are talking now. First inside the constructor. Constructor how to declare init. Inside the constructor how we can access static variable init sir it is. Inside the constructor how we can access by using self or class name no yes. So I'm taking print self dot a using class name sorry using self and using class name also we can take print class name is what test dot a like this. This is inside the constructor. Let me give clarity here. Print inside the constructor. Okay. Same here. Next point is inside the instance method by using self or class name. Inside the instance method. Inside the instance method means this is df m1. M1 is an instance method. Instance method also is having a variable called self first parameter. Here inside the instance method, I'm taking this one again using self or class name, but inside the instance method it is. You know how to recognize instance method. Method with self, and here you can see method with self. This is instance method. In this instance method, I'm able to access static variable using class name or self only. Next, third point is inside the class method using CLS or class name. So I'm taking class method here. Inside the class method, for example, M2 is class method, I can say. CLS is my variable, but it doesn't mean that it is a class method. Class method, how do we make? Class method decorator compulsory required. After that, here print CLS dot what actually a, then print class name dot a. So using class variable through we can access and class name through we can access. This is inside the class method. Inside the class method. Class method inside the class method. Okay. Next, what I'm trying to say here, df static method I'm taking M3, and this static method don't have any self or CLS. You can see this. I'm just taking at the rate of static method decorator. Then only it'll accept a static method only. So using static method inside static method, inside the static method, how to access your uh, static variable? Only class name. Yes, only class name. Because static method declaration time, we don't use any CLS or self, obviously. So that's what here inside the static method by using class name only. Outside of the class by using object reference or class name only. So outside of the class means after creating object for the class. I'm trying to create object for the class. You can see here T is my object reference equal to test. And I'm calling all the method first. M1, M2, M3. Here print outside of the class. Outside of the class, we can say outside of the class, how to access static variables. One option is object reference dot a, other option is class name dot a. Okay, so this is the program to demonstrate how to access static variables clearly. Static variable means the variable which is declared inside the class but outside of the methods. Okay, this is A. So inside the constructor, we can access static variable using self or class name. Inside the instance method, we can access static variable using self or class name. Inside the class method, we can access static variable using CLS or class name. Inside the static method, we can access static variable by using class name. Inside the outside of the class, we can access static variable by using object reference name or class name like this. So let's run this. Everywhere we can access static variable, and how to access them we discuss here. Now you can see all the ways we can able to access. But how to access, you have to know that. Now, how to delete static variables are? Yes, how to delete? How to delete static variable? We can delete, we can delete static variables anywhere, anywhere by as follows. Anywhere as follows. That's it. As follows means del is a keyword. Del space class name dot variable name. That's all. Only anywhere we can access, anywhere you can delete by using this syntax. We can delete static variables anywhere in the class as follows. Del is the keyword, class name dot variable name. Suppose here I'm trying to delete after construction execution a value print here, again a value print here. After constructor execution, immediately I want to delete static variable. How to delete? Del space class name is what? Test dot a. That means here only static variable will be deleted, sir. And this static variable once we delete here, and it won't available for M1, M2, M3, and here also. So you know, as soon as when we create object to the class, who will execute? Constructor will execute. Constructor part, we can access static variable here. And after constructor execution, immediately we are trying to delete this static variable test.a. So here only it's deleted, and here it will not available for this. Look at here, once I run this, only inside the constructor, we got the static variable value 100, 100, but inside the instance method, no attribute and other not at all possible. Okay, because we have deleted static variable inside the constructor only, but it's not possible to access inside the instance method, inside the class method like this. For example, I am trying to delete now after execution of instance method like M1 only. I'm deleting instance static variable. after execution of M1 method. Now M2 method and M3 method, or M2 method, M3 method, this variable is not available. You can see inside the constructor only possible, inside the instance method is possible, but inside the class method not possible. Here error is coming. So you can delete anywhere static variable by using what actually del space class name dot variable name. This is about complete information related to static variables. Why I just wait static variable discussion for more means I just wait for these methods. So once we complete this method, so later I have to discuss actually. So I'll discuss these static variables now. I just discuss about this. Wait because of to complete this one. Already we discussed this methods in the last session. That's what I am just covering today here, static variables, how to access and how to delete them. So these are the very important fundamental basics which is related to object-oriented programming. Every Python programmer must and should aware of these variables and these methods, especially in terms of object-oriented programming. Then only you can able to understand further upcoming object-oriented programming features. Okay, so let's start another concept before going to start features of object-oriented. Actually, features we'll discuss in tomorrow onwards. We'll discuss features, encapsulation, polymorphism, abstraction, inheritance, all these things. No, even I have not started any one of the feature of object-oriented programming also. Before that, we have to discuss some more topics here. So we know garbage collector, GC. GC means garbage collector. Garbage collector. Okay. What is garbage collector here? In the first sessions of Python, we were discussed Python is high-level programming language. That means for low-level activities, we need not to write any explicit code for memory management, all these things. And because the reason is in Python, garbage collector is there. This garbage collector will provide automatic memory management, automatic memory management. So automatic memory management it will provide. Garbage collector will provide automatic memory management. What is automatic memory management here? Automatic memory management means whenever we prepare the logic or any objects we create in our program, and during the program execution time, our objects require some memory space. But who will allot memory space for our objects? Garbage collector. Okay. So that is what here it's provide automatic memory management. I'm saying we are not going to write any code explicitly for maintaining memory. But how garbage collector will work? See, in general, in old languages like C++, in olden days, programmers were write lot of code for memory management also. But when it comes to nowadays, in any language, you can take Python, Java, .NET, or else. Okay, inbuilt garbage collector is there. So this garbage collector will take care automatically memory management. So that's what no need to write any explicit program for memory management. But here, garbage collector, every program it will work. That means in Python programming, every program is having internally garbage collector. But by default, it is activate only. So how do we check garbage collector is available or not? So there are some methods are there. You can see is enabled method is there. Is enabled method. It return true or false. Boolean expression it is. It return true or false on. So if garbage collector is enabled for your program, it return true. Otherwise, it will return false. Next one, okay, disable method is there. Disable method. This disable method is used to disable garbage collector explicitly. To disable, to disable GC garbage collector explicitly, explicitly, explicitly. Third one is enable method is there. Enable, and this enable method is to enable garbage collector explicitly. To enable garbage collector explicitly. Explicitly to enable garbage collector, then we use enable method. So these three methods are there just for checking whether garbage collector is working or not. First method is enabled will return true or false. If it is working, it return true. Otherwise, it return false. Disable method to disable garbage collector explicitly. Enable method to enable garbage collector explicitly. But all these three methods are present in one module called GC module. If you want to work with above methods is enabled, is disabled, import GC is compulsory required. Let's flip to program and let's check it now. For example, I'm taking one program called test 10. In this test 10, I want to check garbage collector is working or not. So for that, I'm taking built-in module, import GC. So how to check? Print GC dot is enabled. I'm passing now. Is enabled method is used to check whether GC is enabled or not. Now you can see true. That means for this program, test10.py garbage collector is active mode only here. Okay, print GC dot is enabled. And if you want to disable garbage collector explicitly, then GC dot disable we can use. And how do I know that after making GC dot disable whether garbage collector disable or not? How do I know means again we can check GC dot is enabled method. Then we can come to know that whether garbage collector is enabled or not. Yes, it is disabled after successful disable. Again, can we enable? Yes, we can say this enable print GC dot enable. Now you can see GC dot is enabled method is there, is enabled. Now you can see true, false, and true. True, false, true. Okay. So GC dot is enabled, GC dot disable again. Again, enabled, that is false. Enabled, yes, is enabled, true only. First we did checking whether it is inactive or not. Yes, it is active. After that, we did disable, means false. And after that, enable, that means true only here. This is the way to check whether garbage collector is active mode or not for this program. And most importantly, what I want to discuss here about destructor. Generally, uh, garbage collector main purpose is what? Automatic memory management. What is exactly automatic memory management? Means whenever objects are required some memory, we should allot memory to the objects. When the objects are not required memory, some objects are ideally sit in the memory. For that purpose, we have to destroy memory. That means automatic memory management is the process of allocating the memory which objects are required really and deallocating the memory which objects are not required really. So memory allocation and deallocation process is called automatic memory management. It will do by garbage collector. But when the situation to deallocate the memory for particular objects, in that situation, garbage collector internally will call a destructor. Yes. First time I'm talking about destructor So even actually destructor we need not to use anywhere, because this destructor can be used by garbage collector only here. We know constructor. Constructor name is what, sir? In the last program we discussed constructor name is underscore underscore init. This is initialization. But I'm talking about destructor. So what is destructor here? So how constructor is a special method of class. Same here. Destructor is a special method of class. Special method of class. Destructor is also a special method of class. And next, destructor name is destructor name is destructor name is underscore underscore del underscore underscore of self. Self is the first parameter of destructor, also same like constructor. So destructor name is underscore underscore del of self only, sir. So when destructor will execute, so whenever object is don't require any memory, okay, so internally garbage collector will call destructor. It is a special method and for deallocation process, and destructor responsibility is only for deallocating the memory, and destructor will never destroy the object. But many of them will think that destructor is the purpose of deleting the objects. No, destructor can never delete the objects. Only garbage collector will call destructor for performing cleanup activities. That means deallocation of memory clearly. After destructor execution successfully completed, then at the end of the thing, who will delete the objects means garbage collector only will take responsible to delete the objects, sir. Okay. So let me show you one quick example with the destructor now. So let's add one simple program, test 11. In this test 11, what I'm trying to do here, you can see I have to create a class. Class name is test. And you know that constructor is available. Constructor will execute when we create object to the class. Now self dot a equals to 10. Okay, constructor. I will directly can write something inside constructor. Print constructor execution. Now constructor execution after immediately I'm checking destructor execution del self. Print, just I'm trying to show you destructor execution is available or not. But actually nowhere we are using destructor explicitly, because this is implemented by using garbage collector only. So garbage collector will implement automatically destructor. It will call whenever it is required. So just I'm showing you clarity purpose. You have to understand whether destructor will be execute or not internally. Okay. So always destructor will be execute in the following of constructor. That means constructor means to build something. Destructor means to destroy something. Some at the time of constructor, memory will be allocated once your execution is complete for your class references or object references. Automatically, destructor will execute for cleanup activities. So I'm just creating class here and test. Next, when we create object to the class, who will execute by default? Constructor. So constructor execution, constructor execution. Once constructor execution complete, then immediately what will happen? Destructor execution. Del print destructor execution is there. So destructor execution is happening. Yes, why not? You can see constructor execution, destructor execution. And even I'm trying to show you import time, and I need to wait some time dot sleep off. 3 seconds I want to wait. Then after that you can see destructor will execute or not. You can check it once. Constructor execution, waiting 3 seconds. After completion of 3 seconds, destructor also executing here. So this is the destructor execution process, but we are not going to use anywhere destructor in our programs because this is used by garbage collector internally. So destructor responsibility is what? Memory cleanup activities. Destructor will not at all delete the objects, and after completion of memory cleanup activity, who will destroy the objects? Finally, garbage collector will destroy the objects clearly. Okay, so this is about today's session, which I want to discuss. In tomorrow, we'll discuss again, that is inner classes, outer classes, how to work, and after that, immediately we'll begin with object-oriented programming features one by one, like encapsulation, polymorphism, inheritance, abstraction, and so on. Okay. So if you have any question regarding this session, please ask me now. We'll continue tomorrow.